Roadmap to Clean Energy Using Laser Beam Ignition of Boron-Hydrogen Fusion. Number 4. Problems to be solved. The open problems for the single beam cylindrical HP11 fusion reaction as a detailed mechanism in the ignited cylindrical reaction plasma. The basic step is the combination of the well-developed non-thermal equilibrium, initiation of the reaction blocks driven by forces of the laser plasma interaction, together with the new trapping kilotesla magnetic fields as the key process. The plasma block ignition is fully explored based on the initial fusion flame generation, using ultra-high acceleration of plasma layers as measured from blue shifted spectral lines, is in exact agreement with theoretical prediction. The trapping of cylindrical targets by more than kilotesla magnetic fields was shown by computation under temporary constant conditions of the magnetic field. In reality, the capacitor magnetic coil fields in Figure 3 are not constant and have a completed spatial and temporal development, while the fusion reaction process in the full, well evaluated for 1D geometry, will be modified. This accessibility will indeed give the chances for well advantageous conditions for selecting the best time frames for scheduling the block ignition of laser 2 with the constant time of the laser 1 for operating the capacitor coil of Figure 3. These conditions have to be studied well with techniques available in established laboratories with sophisticated technologies parallel to specific computations using hydrodynamics or particle in cell (PIC) method. The knowledge gained from this research will lead to generalization of the properties of the laser pulse. 1. With respect to focusing time dependence and the incidence angle of the beam on the capacitor plate. The extreme laser pulse has, first of all, to be generated with a very perfectly controlled suppression of pre-pulse, though these pulses are normally of 1 picosecond duration or shorter. Their temporal pulse shape can well be modified by now available control. This also will give some variability for the temporal scheduling. In view of magnetic field development under the control of laser 1, these are rather sophisticated experimental tasks, but are not new and have been solved before. Another possibility to optimize the conditions for the fusion process of the conditions of the full may be if the magnetic field will not only be cylindrical symmetric geometry but may get an additional conical component by modifying the coils in Figure 3 in an asymmetric way with respect to the axis. While studying the mentioned parameters, there is one question: how the full in Figure 3 is behaving within the ultra-high magnetic field, even without irradiation of the pulse from laser 2 for the fusion ignition under the growing magnetic field in the coil. It will be interesting to find out how the full substance or any other material will behave under the extreme magnetic fields before reaching the range of kilotesla and more. Will an ionization happen, and under what magnetic field strength? This kind of magnetic field ignition is a topic that may never have been studied before. If a plasma would be generated, or how this may be controllable by providing or reducing a certain electric conductivity. In the full, under the extreme conditions, this all may be a further new parameters that can be developed for optimizing the conditions of the new type of cylindrical fusion reactions in Figure 2 and 3, differing from the highly explored fusion in spherical full targets. Progress in this research, but not as a condition of high priority or necessity, is a new direction to study the non-LTE conditions in plasmas as a basically new task for theory. The long desire of the non-mesentery clean HB11 reaction is of such high interest that all attempts are to be considered to achieve this under the conditions of non-thermal equilibrium and using non-linearities. These conditions are best given by laser using high plasma densities near the solid state and are filled with the highest laser fusion gains measured, repaired, and even increased by a factor 10 and directly visible from the analysis using elastic nuclear collisions. A very important new approach is the result of proving these non-equilibrium properties by theoretical equilibrations of NIF experiments. The research for low-density plasmas for HB11 reactions is well underway, especially with the Tori Alpha Energy project, of which the reverse magnetic field design is a modification of the cylindrical version of the Hatch-Melley configuration of intershell electrostatic confinement IEC. With all these configurations, not any HB11 fusion was measured yet in these low-density plasma, while the laser experiments arrived at the super high reaction gains above those from DT. The extensive studies of plasma science 1940 have gained an enormous amount of results with very numerous unexpected discoveries, where the new developing work on HB11 fusion is only one of the subdivisions. How this explosion of science is crucial for the enormous problems ahead was very well envisioned by the formulations of the problems of plasmas by one of its greatest masters, Edward Taylor, on the background also of the complex problems discovered and pioneered by Lord May of Oxford as fan-dimensional orientation. Thank you.